Okay, so this is CIS 216. CIS 216 using regular expressions using GREP. So kind of what we want to do is follow along with using more about regular expressions. We're going to use regular expressions in GREP though. So the files you're going to need are superheroes.txt, your Linux computer, and then GREP to kind of do this. So what is GREP? GREP searches for named input on files, all right? It's standard input if no files are given. It can also match the given pattern by default. GREP will print out the matching lines. And it's kind of interesting because you've got to remember what your standard output is going to be, the TTY, in terms of the computer screen itself. In addition, there's two variant programs called eGrep and fgrep that are available. They're the same thing, but they all do stuff a little bit differently. So eGrep is the same thing as grep minus E, and fgrep is the same thing as grep minus F. And it kind of makes it a little bit easier, especially if you're doing this from a programmatic side. There's some really important grep switches that you want to remember. So remember, eGrep, extended grepping with a regular expression that you can actually nest in. You can interpret a pattern using a regular expression. And then G is a basic regular expression. You can interpret a pattern just based as a basic regular expression, and that's basically what we're going to be working with. One of the really important ones to remember is minus lowercase I, and that means just ignore the case. There's a lot of Linux that's case sensitive, so if you're searching a file, you really want to try to keep your searching as case insensitive, because you never know how someone's going to type, especially when you're inside a file. You can also do a minus N to print the line number that the match was found on. If you have a lot of files that you want to search underneath the directory for a pattern, you can do it as a recursive. Minus lowercase or minus uppercase R will search all the files underneath a given directory for a pattern. And this is really good, especially if you're doing things for, especially with log files and other stuff. You can also invert the match, show all lines that are not matching of the pattern. This is really handy if you want to find out if, especially if you've got a file that's supposed to have zip codes with a user, with a name. You can show all the files that don't have the zip code as part of a username, and that can make life a lot easier, especially if you have to go back through and correct data that wasn't input correctly. So how to parse data in a file using grep. So grep's designed to search for data in a file or a list. So you guys got really comfortable doing ps-ef, pipe, grep, http, right, when you were doing stuff in 2.15 and in 2.17. But if you want to search for a specific item in a text document, you can also use grep. So we have a file that we created called superheroes.txt, and there's about 300 DC, Marvel, Eclipse, Image, IDW, and Valiant superheroes in this list. So it's really quite lengthy, and it's going to be really hard to try to find things if you had to do it for scanning on your own. But if you do grep minus lowercase I man superheroes.txt, it should find everything that has the word man in the file and push it to the screen. So let's go ahead and let's see. So we have our little Ubuntu up here. Right, and what we want to do is we kind of want to bring this forward, so let's drag this out of the way. So if we do that whole thing, which is going to be grep, we do grep minus I man superheroes.txt, and it will show you everything that has the word man in it. So you can see that there's Animal Man, Hawkman, and Hawkman. Two different ways of spelling Hawkman. Power Man, Iron Man, Human Torch, Iceman, Robot Man, Freddie Freeman, and all these others. So it really just drops all of these things out. Now the cool part is that you can also pipe these out. Remember, if we use the 2 carets of pen to dan.txt, right, and it will just go ahead and drop it right to the text. And you can see that we actually have 2 text files. And if we go and open up dan.txt, we can actually see there's my list of people. All right, so there's the 2 ways of doing it. So if we clear it and we go grep minus I man superheroes.txt, .txt, that will drop the list to the screen. If we do this and then we just do a pipe out to file.txt, then it just drops everything out to this, and that's how we can go ahead and pull our specific searching within grep. And it really does make life a little bit easier when you're kind of doing this. So you can go ahead and let's try it, right? So we just did the first one, right? But I want you to go ahead and do the grep minus I and search for people who have the word black in there, or search for the word cat, or search for the word spider. You can also do grep minus V minus I spider heroes.txt, and you should see a list of people without the word spider in their name. So you can kind of see how all these things go, and again, you can just pump them out to a text file if you want to, or however you want to go about doing this, right? So remember, grep case insensitive, we look for the word black inside the file superheroes.txt. Look for the word cat, we look for the word spider, and then we look for everybody without the word spider in that file. Right? Now there's some really cool modifiers in here that we can use if we just want to match out specific things. So we use a period, we can match any single character that's inside the string, and we'll look for them all. We can match the empty string and tell it to start at the top of the line, use the $sign to match the empty string at the bottom of the line, so you can move things around and tell it where to start. If we just put in A, it will match all uppercase A's. If we do the lowercase a, it will just match a lowercase a. But we'll match every single one of those inside the file. So it will tag on everything that has an uppercase or a lowercase a. If you have something with a digit, if you do a / lowercase d, you can actually just search for a specific number. If you do a / uppercase d, you can match any non-number character, AZ, AZ. And notice how I wrote that out. Lowercase a minus z, uppercase a minus z. That kind of says I want you to check all of every combination of a through z, both lowercase and uppercase. One of the other things too you can do is you can kind of try to match these out by specific character types. So if you have the a minus e in brackets, you can match any uppercase a through e. So it would tag on a, b, c, d, and e. If you do the caret a through e, it will match any uppercase character but a through e, right? So we'll look for the empty string, and we'll look for those and then go, oh no, wait, I can't do this. So I don't want anything that has an uppercase a or e in them. I want everybody else that doesn't. So that's where this gets to be kind of cool. So you can really start mixing and matching how you want to do your GREP modifiers as you kind of go through this, right? Another really cool way of doing a modifier is if you want to do pattern matching in terms of finding single occurrences. But here's the one thing you got to remember about Linux when you're working with it, right? Is remember binary is 0, 1. So if you do X ? match no or 1 occurrence, and that's it. X will match 0 or more. X plus will match 1 or more. So you kind of have to remember how binary logic works on this one, right? So X ? is match 0 or 1 occurrence of the capital X, and then it's done. The X and the number thingy is match 0 or more, and then X plus is match 1 or more capital X's. Now the other thing you can do too is match a sequence of at least one character type to another one. So if you do ABC pipe DEF in parentheses with the plus, this will match a sequence of at least one ABC and one DEF. So ABC and DEF would both match, and then it's done. It will stop and we'll go on. Okay, I'm done. I found it, and I'm happy, and I'm finished, right? So these modifiers are a little bit more complex, but great if you want to find a sequence of characters within these huge long files that you may not necessarily know what to do. So let's go ahead and try it, right? So what we want to do is we want to do a grep minus capital E, put in quotes, cat, bat, superheroes. This will match names that start with capital BAT, right? So what would I use to make it not case insensitive? We just throw the minus I in here, the minus lowercase I. So if we do grep capital E, bat, bat, cat, cat, superheroes.txt, it will match all lowercase and uppercase bat and cats in the file, right? If you do grep minus E, bat, cat, it's the same thing as the second one here, right? Because we don't really care about whether it's case or case insensitive. And the bottom one we say, okay, we just want everybody, we don't care if it's sensitive or not. So 2 and 3 here you can basically are functionally the same, but it's a little bit less typing, right? It just all depends on where you're at with this. And then this last one, grep minus E, bat, superheroes, excludes all lowercase b followed by AT. So we're kind of excluding stuff out of this one to kind of go along with it. So I want you to go ahead and try those as well as you kind of get through this list so you can kind of see it. So it kind of makes it interesting. If you want to, just feel free to go ahead and remember to pop these out as a text file, and you can just put the text file in the core shell and be good to go. But again, this is a really simple way of doing it, and a really nice way of just kind of using grep to kind of slice and dice your files, so you can kind of see what's going on with that. And then I kind of want to also go about what we have cooking with your program. So we're going to go in here and take a look at our first script that we have. So we have something called broken script. All right, so broken script is pretty much so a really broken script. So we have a broken script here. All right, so last update was 4/26/2011, so we know it's a little bit old. So the things you're going to want to look for when you're trying to fix broken script number 1 is to make sure that it's all pointing to the right spot. So when we talked about this earlier, we're talking about bin sh. So this calls up a different shell, and your Unix box may not have the bash shell. So if you want it really transportable, remember to take it and just make it bin sh, right? And then we have the name, we have another name, timing script, and who it was written by, and then last time it was modified, who modified it, and then the last time it was updated. All right, and then this is going to be parsing and timing a file. So we know what this script is supposed to do. All right, we have a clue. When you guys go through it, you're going to say it was modified by, and remember, we want to make sure that there's no typos in here, right? Because when people take a look at typos and they see typos in your script, they may think you're a sloppy coder, right? Then we're going to go ahead, when we fire off the script, it clears the screen. Now, that's not a proper directory, so we want to make sure that that directory is cleaned up, and we want to make sure that it's actually in home superheroes.txt. If we take a look at our student bit, right, if we take a look at our system, you'll notice that we're home student documents. If we try to go to home / superheroes.txt, it's not going to know what to do with it. So we have to make sure that the file that we read is actually really truly available. And then we want to have an out file that's being parsed by the script. So we have to tell it, I want you to drop something in here. And we have an unterminated quote. So there's all sorts of things wrong with the in file, and there's all sorts of things wrong with the out file. And these caps will matter, right? And then what they do is they go ahead and they create a function called readline, and they call it parser, and they just open this up as a method. Now, interesting part, they went ahead and they took out and commented out function cat-var readline, and then put it in brackets, and then they zero out the out file, but our out file isn't called right? There's extra characters in there. And then in file, does in file actually go right? A cat in file, so we cat this file, so we open it up to read it. And while it reads each line, we want to do a grep on ABC : XYZ. So that may be wrong, but we want to make sure that our line and all the rest of this stuff actually matches out. So there's all sorts of typos in here. But remember, it appends to the out file. So it clears it when you first run it, right, by using the single quote, and then it appends whatever was in the line, and then it says it's done. Then it says time and parse the file. So starting to parse the file, it sleeps for 1 second, and then this may take a while, and then it sleeps for 20,000 seconds. And then date is wrong, and if we're going to do date and time, if we're going to parse file and difference in seconds, one of these should be date and one of these should be time. And then we're also calling an unknown variable x on our difference, so it doesn't know exactly what to do with it. And then it echoes file parsed in diff seconds. So are we really calling this one correctly in terms of setting it up as a variable? Then it sleeps 100,000 seconds, and then it says have a pleasant day, and then sleep 22,000 seconds. So we really want to try to make this a little bit easier for the people that are actually going to have to run this script. So you may want to cut its sleep down, and you may want to make sure that you're actually doing a date and time for this calculation, and make sure that what you're calling E and S is actually represented in the diff for those two things. So that's basically what the issues are with broken script number 1. We have some weird stuff going on up here in the top. This is definitely going to be taking some work, and it's not really commented right. File being parsed, file being input. So you really want to go back and probably go through and start fixing all these little problems with it, and then debugging it and testing it and making sure that you're pretty well good to go on terms of what you want to do with it. So what I want you to do is go ahead and give each one of these regular expressions a good try, right? And then go ahead, this is your homework, go ahead and push them up into Angel so I can actually see them. But give these things a try and see what you can do with it. It's relatively simple, straightforward. It's not a big deal. All you've got to do really is just kind of cut and paste from here and just give it a shot and see what you've got, and then start really taking a look at what you've got going on here and making sure that you can actually do this programmatically within the script itself on what we're looking for and how we want to look for it. And then the user portion of this is pretty messed up in terms of waiting, days, if not hours, if not months, to actually get an answer back from that. That will generally tick off a user pretty darn quickly. So go through those files, have a good time with it, and don't forget to give me any questions that you may have.